Alright, so here we are looking at solving problems using quadratic models. This is actually example 3, that's on page 428. So you've got a 10-meter high platform and a swimmer's jumping off it and then landing in the water. Okay? So they tell us that the two divers reach their maximum height of 0.6 meters above the platform. Well, if this is 10 meters above the water here, then this right here is 0.6 meters above the 10. So that would make sense that this is a height of 10.6 meters. Okay? And they tell us that it happens after 0.35 seconds. So this tells me really that this x coordinate right here is 0.35. So I can write this point as an ordered pair. So it would be x is 0.35, comma, y is 10.6. Okay? So if you see, they've actually given us our vertex here, right? Okay? So they're asking how long did it take them to reach the water. So essentially they're asking you for this time right here, right? An x-intercept, really. You might notice that if I extend my axis in this direction, I'm also going to get another x-intercept right there, but it's going to be a negative time value. And a negative time value is essentially before you jump off the platform. So in the context of this problem, this x-intercept that we find won't be applicable. Okay? So I mentioned that we did get given the vertex here, so that means I can write vertex form. So vertex form is actually y equals a, x minus h squared plus k. Of course, this 0.35 here is h. This 10.6 would be k. So to write vertex form, I would just have y equals a, x minus 0.35 squared plus 10.6. Alright? So now, I have most of what I need for this quadratic, actually. I need to find out what function exactly models this curve. And then once I know what function models the curve, I can really just use the quadratic formula to find out what these x-intercepts are by setting the height equal to 0. Okay? So I need to find this a value to model the function. So what we do when we're trying to find a values is we find another point that's on the curve and then substitute its coordinates into the equation for x and y. So do we have another point that's on this curve? Well, we're told that the platform is 10 meters high, so this is at the very beginning, before you've jumped. So this would be a time of 0 and a height of 10. So we do actually have another point. It would be x0 and y10. So I can plug 10 in for y here and 0 in for x here. Okay? So I'll do this over here. So I put 10 in for y, so I've got 10 equals. A I still don't know. X is being replaced with 0, so 0 minus the 0.35 is still here. Of course it gets squared because it's a quadratic. And plus 10.6 at the end. Alright, so now we can evaluate this in the brackets here. So 0 minus 0.35, of course that's negative 0.35. It gets squared. Alright, so now I do this piece here, negative 0.35 squared. So that's just negative 0.35 times negative 0.35, which gives me 0.1225. So a times 0.1225 can really just be written as 0.1225a, and then plus the 10.6. Okay? So now I've got one equation with just one variable, so I can solve this for a now. To do that, I would need to get rid of the 10.6 and then get rid of the 0.1225 to get a all alone on one side of the equation. So let's get rid of the 10.6 first. Usually get rid of addition and subtraction first. So this 10.6 is added on. So to get rid of addition, I would subtract 10.6. Okay? Because 10.6 minus 10.6 gives me 0, which effectively gets rid of that 10.6, which is what we wanted to do. Of course, what you do to one side of the equation, you need to do on the other side of the equation as well to keep left-hand side equals right-hand side. Okay? So 10 minus 10.6 is negative 0.6, and it's equal to 0.1225. oops, missed a 2 there, 5a. Okay? So now, to find a, I need to get rid of this 0.1225. So since it's multiplied by a now, I need to do the opposite of multiplication to get rid of it. So the opposite of multiplication is division. So I divide by 0.1225. Of course, what I do to one side of the equation, I need to do on the other side of the equation. So divide by 0.1225. So 0.1225 divided by 0.1225 is just 1, which effectively cancels this off, giving me just 1a, or just a. And then I can divide negative 0.6 divided by 0.1225. I'll round this to 1 decimal place. It comes out to about negative 4.9. Okay? So now I've actually got my quadratic, because I had this to start with, but now I know what a is. It's negative 4.9. So the quadratic function that models this curve is actually y equals negative 4.9 x minus 0.35 squared plus 10.6. You see, all I've done is I've taken this equation and I placed in the a value that we just calculated. Okay? So now, in the context of the problem, I need to find out when we're hitting these points here, right? Okay? Well, y represents the height, and t represents, or x represents the time. So if I want to find the how long it takes to hit the water, well, what's my height when I'm at the water, at water level? Well, if I'm at the water level, that means I'm 0 meters above the water, right? So what I'm going to be doing is taking this quadratic function or equation, and instead of having y here, I'm going to say, okay, I want to be right at water level, so that means I want my height, or my y value, to be 0. So I will write in 0 equals negative 4.9 x minus 0.35 squared plus 10.6. Okay? So this is actually what we're doing when we're solving quadratic equations. So now, I still can't do a whole lot with this just yet. I actually need to convert it to standard form. Remember, standard form of a quadratic equation looks like this, and what we have actually looks nothing like standard form yet. So I need to convert this to standard form. Okay? You may have already done that working through the unit, but here's how you would do it. So you could write x minus 0.35 squared is really x minus 0.35 times x minus 0.35, right? Anything squared is just multiplying by itself, right? And then the plus 10.6 at the end. So you see, the only thing I did is I replaced this with this, okay? So now I'll multiply this out. I'm leaving the negative 4.9 here. I'm actually going to write a big bracket here. So x times x, using my distributive property, is x squared. Then multiply this x by this term here. X times negative 0.35 is negative 0.35x. Then distribute the negative 0.35 times x is negative 0.35x. And then distribute the negative 0.35 to the negative 0.35, which gives me a positive 0.1225. Of course, don't forget I've got the plus 10.6 out here at the end. Okay? Let's tidy this up inside the big bracket here. So I've got 0 equals negative 4.9 x minus x squared minus. I can put these two terms together because they're both x terms. They're common, they're like terms. So negative 0.35x minus 0.35x is negative 0.7x. Plus 0.1225 and the plus 10.6 at the end. So now what I'll have to do is distribute this negative 4.9 in through the stuff inside that big bracket, right? So this gives me negative 4.9 times x squared is negative 4.9x squared, and then negative 4.9 times negative 0.7x gives me a positive 3.43x. I'm rounding here a little bit. and then negative 4.9 times positive 0.1225 is a negative 0.60025, and then I've got my plus 10.6 at the end here. So I'm starting to look more and more like standard form. I've got the ax squared plus bx, but I've got two constants here, so what I'm going to do now is group those together. So it's negative 0.60025 plus 10.6. Well, that's going to clear it up for me. So I've got negative 4.9x squared plus 3.43x plus, put these together, it gives me 9.99975. So now there's standard form, ax squared plus bx plus c. So I can tell that a is negative 4.9, b is 3.3, c is 3.43, sorry, c is 9.99975. Okay? So at this point I can use my quadratic formula to solve for the x value. So I've got a equals negative 4.9, b equals 3.43, and c equals 9.99975. Okay? So our quadratic formula looks like this, of course. Alright, so negative b, that's a b, not a 6. Well, b is 3.43, so negative of b would be negative 3.43. Plus or minus the square root of b squared would be 3.43 squared minus 4. A is at negative 4.9, negative 4.9 times c, which is 9.99975. Okay, all over 2 times a, which is 2 times negative 4.9. Alright, I work at what's underneath the radical right now. So 3.43 squared. So 3.43 squared equals 11.7649. Alright, so now I'm going to be careful with my signs here. I've got negative 4 times negative 4.9. Okay? So I'll show you me punching this in the calculator if you can see that. So negative 4 times negative 4.9. So that's the first two terms multiplied together. And now I multiply it by the third one, so times 9.99975. That gives me 195.9951. And it's positive, so it's going to be a plus sign. 195.9951. Of course, it comes out to be positive because I've got a negative times a negative here, which gives me a positive. All over 2 times negative 4.9 is negative 9.8. Alright, continuing with what's underneath the radical now, I'm going to put these two terms together. So it's just 11.7649 plus 195.9951. So that gives me 207.76. Alright, so now negative 3.43 plus or minus, I take the square root of this, which gives me 14.41 over negative 9.9, negative 9.8. So I've got two answers here. So the first one is going to be negative 4.43 plus 14.41 over negative 9.8. Alright, so negative 3.43 plus 14.41 divided by negative 9.8, which gives me a negative 1.12. Alright, the second one is when these will be subtracted, so negative 3.43 minus 14.41 over negative 9.8. This actually gives us the answer that we're looking for, which is 1.82 seconds. Of course, we can't have a negative value because that's actually the time before you've jumped off of the platform. So it takes 1.82 seconds to reach the water.